Alright, good evening, morning, afternoon, etc. I'm Mr. Venable, and today we're going to be talking about converting from base 2 numbers, or I call these, we think of binary numbers, binary code, to base 10 numbers, which is our standard numbers that we're dealing with. So, if you missed the previous video where we talk more about the binary system, converting from base 10 to base 2 numbers, make sure you check that out so that you're not lost here. But the binary system is based on powers of 2, whereas our number system is based on powers of 10, right? When we say base 10, 10 to the first, that's the tens place. 10 to the second, the hundreds place. 10 to the third, thousands place. And of course, 10 to the zeros, the ones place. So that's why it's called base 10 and base 2, because it's dealing with exponents there. So let's say we have a number. I want to get rid of these rule lines that are in the way. They just help me draw my little grid here. Alright, so I want to look at a number in binary. It's just a series of ones and zeros. So let's say we have 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1. Okay? So I'm going to write that number here in my little slots here. So I'm going to start from the right to the left. The 1, we got a 0. We got a 1, 0, 1, 0. Ooh, man. So 1, 0, 1, 0, 1, 0. 1, 0, 1, 0, 1, 0. Alright, so I got 1, 0, 0, 1, 1. Alright, so just double check that. Here's those. So that's these from here to, I think, this 0 here, and then 1, 0, 1, 0, 1. Okay, now I'm confident that I at least wrote it correctly. Alright, so this doesn't read. You might read this, if this were a base 10 number, you might put commas in here to help you read it. And, You'd read this as 1 billion, 100 million, 101. Actually, I'm a comma behind here. So we'd put commas here, and this would be about 11 billion, 1 million, 10,101. But we don't read that as that. We read it again. This is. I'm saying that this is base 2. So it's based on powers of 2, right? 2 to the 0 power, 2 to the first power, 2 squared, 2 cubed, 2 to the 4th. 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, and then 2 to the 10th. So the powers of 2 are 2 to the first. Remember we said everything to the 0 power, except 0 of course, is 1. 0 to the 0 power, it's just not a real number. Alright, 2 to the first is 2. We have 4, 8. This is worth 16. 32 times 2 is 64. Times 2 is 128. This is 256, 512, and 1024. So this number, just like we'd have expanded form for numbers, this number is actually worth, alright, 1024, because this is 1 is in the 1024's place. Alright, then we have, this is worth 2 to the 9th, which is 512, so plus 512 plus, now we don't put anything, we put essentially 0 times 256 added to this, which is just 0, because there's a 0 in the 256 place. Alright, there's a 0 here in the 128th place, and just to help me keep track of it, I'm going to put 0 times 128. I know that's nothing. Then there's a 1 in the 64's place, so it's 1 times 64. Again, I know that applies to 64, but just to help me keep track, plus 0 times 32, alright, plus, in case you're getting lost where we are, now we're here, so plus 1 times 16, alright, now we're here, so we do plus 0 times 8, alright, and then plus 1 times 4, plus 0 times 2, plus 1, and I'm kind of running out of room here, 1 times 1. Now I add all these numbers up, and because I'm a mathematician, I am, of course, lazy. I like, you can use just your standard calculator here if you look in your menu, and we can go and use that. I actually prefer to use my TI 83 calculator. It just kind of takes up a little more space. So if you have your TI 83s, for those of you who are, allowed to use those, you definitely want to get those if you're in a geometry class or advanced math class, algebra 2, but they're a really useful tool. But I'm just going to add these numbers up, and this thing takes, the program here takes a little while to load, but it's a really great program, really great emulator software, and I'm starting to regret opening it, because it's killing my time, and I don't have to edit the video, I just want it to slap together. So, and I got my pink calculator here, so I got our pink calculator, So, you know, for if we have any people who don't like pink, you know, can make that orange, or can make it. I'm feeling blue today. Feeling blue. All right. So, and I can go ahead and add all these numbers up. So I'm going to use my regular calculator because this is getting in the way. So we have. I'm going to add 1,024 plus 512 plus. Okay, these are all zeros, so plus 64 now. And you can see the running total. Make sure you're adding them correctly. Plus 0 times 32, so 0. Plus 1 times 16, which is 16. Plus, all right, we got 0 times 8, which is 0. Plus 1 times 4, which is 4. Plus 0 times 2, which is 0. And then plus 1 times 1, which is 1. So this is actually, this number, it's not 110 billion or anything like that. It's actually just the number 1621 as a base 10 number. So if a computer, for instance, someone who knows binary code sees 100,010,101,001,01, they might read that. If they know how to read binary, they would just instantly read it as 1621, which in our minds, it's not as clear as, hey, how much is this string of numbers? Because we're so familiar with the base 10 system. But here, this is a method that we can use to convert it, to understand how to communicate between different number systems. Later on, we'll do some things, maybe base 3 number systems or base 4 number systems. But this is just kind of fun to know. All right, so thanks for watching, and I hope this helped you out.